It might not say, sometimes it's if you put it in and you don't actually hit save and you forget to do something else. I do every once in a while, that'll happen to me.
Like, I was grading my notes, took my notebook, I started my computer, but my grade's still at a 0.
I would ask her, I mean, just say, hey, I was watching you when you put it in, but my grade still shows a 0. Well, hey, it doesn't matter. Keep in mind or say, hey, I'm still not seeing it. I'm missing something.
Getting an 8 out of 20 for grade, I'd rather get an 8 out of
Oh,
20.
yeah, you don't want to do it.
Yeah, I take 0.
All right, so phones should be up, earbuds should be out, headphones should be off, AirPods should be out, whatever you call them, all that stuff. All right, so we got a lot to do and a short time to do it. You're taking the same quiz Tuesday and you're taking the same exit ticket no matter how much I give you. Let's move through it. Tuesday is your quiz. So you have an exit ticket today, which we've already done the stuff on last class. And then next Tuesday is the quiz, which isn't easy. All right, so I'll tell you what's on the quiz. Don't worry about the quiz yet. Let's get through the material so that we have time for me to talk about the quiz. All right, so first question, we've done the first one. What do we say perpendicular means? Well, it actually does have some congruent angles in it, but more specifically what it means. That's the key. Perpendicular has to do with forming right angles. I'll just show you, I mean, perpendicular is also on the wall. Remember those right angle symbols mean that those lines of the bricks are perpendicular, but the picture was sort of like that in the book. It was tilted a little bit, so it doesn't have to be straight up and down and straight left and right. If I have two lines that cross and they form one right angle, they are perpendicular. Because if they form one right angle, every angle has to be 90. No exception to that. And we're going to go over why that's the case. Right now, just know that's what perpendicular means. Two lines that are perpendicular form 4 right angles. No exceptions. Supplementary means what? That's all. We didn't do that, but good. I got to wait 2 people. Can't call them yet. Take a guess. Has to do with the number. 180. Good. So if two angles add up to 180, then they are supplementary. That's the definition. Two angles that add up to 180 degrees are supplementary. I'm going to kind of. Yeah, let's skip it. Or let's skip 3 and come back to it. What's true about number 4? Has to equal to 180, right? We did that yesterday. We said if I take, so I'm going to erase that. Remember, this is recorded. If you miss anything, you can go back and fill in gaps. If I take a straight line, could be a line segment, could be a line, either one. How many degrees in that? We just said 180, right? Like, if you forget that a line is 180, here's 2 quick ways to remember. 1, how many degrees in a right angle, we said. Most of you know that one. 90, right? So if I take a right angle and I add another right angle to it. Oh. So again, take a right angle, right? 90 degrees. If I then add another right angle to that, so I would have a straight line on the bottom, right? Well, 90 plus 90 is 180. So if you struggle to remember for some reason that a straight line is 180 degrees, just know, well, yeah, that's right. And you can look at the wall. This 90-degree angle and this 90-degree angle means that line has to be 180 degrees. That's one way. Another way is how many degrees in a circle? Most of you know that number. 360, right? If I turn all the way around in the circle, I just turned 360 degrees. So if I drew a straight line through that, like the diameter, basically, if you remember what that means. I took a circle. And if I drew a line made semicircles, so half a circle, how many degrees would have to be in the semicircle? So that means that line would have to be 180 degrees if half a circle is 180. So 2 ways to try to remember it. Most of you, I think, are probably going to be good that a straight line is 180. You'll forget when to use it. Like you'll forget about that fact. But if I ask you how many degrees in a line, you'll be able to answer it correctly. So the connection most of you are gonna need to make is you need to be thinking, do I have a straight line, which would mean I have 180 degrees. I'll also do this a lot to remind you of that. If I can draw a semicircle through two angles, then I know that those angles have to add up to 180 degrees, which is what this problem is about. I know the line is 180. All I did is just split that line into two angles. So therefore, the two angles have to add up to 180, right? If I didn't change the line, I just made two angles out of it. What concept is that? That we've done several times. Did it in the line segments. We did it again in angles. Little plus little has to equal the big. How do I lose stuff so bad? Oh, that is one of the little angles, right? I split it. This ray right here, that ray splits the line into two angles. So this is one of the littles. That is the other little. And then the big is the line itself. So I don't have to give you the measure in degrees if the big is a straight line. So that's when you have to know that the problem is still about little plus little equals big, even though I didn't give you the big. Sometimes if it's an angle more like this, where it's like, I have no idea what the measure is. There's no way I could know. So if I then split that and I want you to do little plus little is big, I have to give you the measure of the big. Or I have to give you enough where you can then solve for the measure of the big. That's possible too. I got to give you something else. I do not have to do that. So your equation, just really quickly, you can check is what? What's the equation on number 4? No, Jensen, you can. No. What's the equation on number 4? Kind of already done what? That's your equation. So remember, it does not matter. Oh, we said what's important about that little circle thing, which means that is about what? If this is about degrees, then what is this about? The whole thing is about what? It's about the measure of the angle. If there's no degree symbol, it's about the length of a line segment. We haven't gotten to that yet, but we will, and kids every year get confused, so I'm trying to introduce that early. If you see that little circle, degree symbol, what it is, degree symbol, that is about the measure of the angle. Now, if there's no angles and the problem's about temperature, then it's about temperature. Occasionally, they'll do a word problem with temperature in it, so it can mean other things, but in angles, it is the number of degrees in an angle. So if I know that's the measure of one angle, doesn't matter that it's got a 7, an X, and a 5, that is the measure of that angle. Right now, we just don't know what it is. We don't know the exact number, but hopefully we're going to be able to solve for it. That 4x plus 10 is the measure of that angle. Don't know what it is yet, but hopefully we can solve for x and then solve for the angles. And then I know the line is 180, so that's my equation. Little plus little equals. I'm not going to solve that out. I have done the video, the algebra video, if I didn't mention that. I did that last night, I guess, and posted it. So it doesn't cover every possible type of algebra that you could need in this class, but probably for the first 2 modules, it covers everything you'll need. Last one. Oh, wait. We did supplementary, right?
Yeah.
Okay, so one thing I got to mention on supplementary then. Anybody? On supplementary, they do not have to be right next to each other. Like these are supplementary. They add up to 180. They don't have to be right next to each other. There's actually another specific definition for that, which we'll do in a minute. I could have an angle there. I'm just going to call it angle 1. Sometimes you will see numbers for angles, and they don't put a degree symbol when they do that. They just put a number to the name. Has nothing to do with the measure of the angle. It's not a 1 degree angle. That's why there's no degree symbol. And then I could have, let's see, it would be a pretty big angle here. If I tell you those 2 angles add up to 180, then they are supplementary. They don't have to be right next to each other for something. Don't think that they also have to be next to each other. They can be, like these are also supplementary, but they don't have to be next to each other. In your book, turn to page 61. I want you to tell me another name for these two angles. There's actually two names you can use. Not yet. One more. I guess this is probably the best time because you need to be in here for the new stuff for sure. I'm not writing anything on it, so stay on the track. So there are two other names you could use for the angles I just circled. Christian, give me one of them. Page 61. Wait, I'm sorry. It's actually not 61. I lied. Page is that? Wait, page is that? Yeah, page 65. Actually, I'm sorry. I think in this class we got to it. We didn't get to it in every class. But give me what is true about those two angles? Which one of those definitions did you use? 65. There's a box that said special angle pairs. It's actually two of those special angle pairs in one image. Yeah, I'm going to have you give me the other one. Just get one. Good thing you're way away from her. She just answered if you heard her. Oh, good. So, where are they at relative to each other? Like what would you like? These are what? Like different than these? How are these two different from those two? Just visually, just explain visually what's different. No math. So it could be a different size. You are right. Now this one's kind of getting close to this one, but that one is definitely skinnier. But like where? Let's talk about where they are related to each other.
Right next to each other.
Shh. Christian. Man, why do you guys all think your name is Christian?
There's an actual word should be.
Yes, that's what I'm trying to do. You heard what Gill said. So here's the definition of that first word. I mean, I think we did it. Adjacent means they are right next to each other, but more specifically, because this is not adjacent. I drew something right there. Those are sort of next to each other also, but they are not adjacent. So what do we say? These are adjacent. These are not. So what is the key to adjacent? Explain it. Do you want to try that one, Bella? Explaining that? Do you want to give me the other? You want the other one? All right, I'll let you give me the other name. Thank you. What is the key to adjacent? You answer me, Luke? Yeah, you could say connected. That's actually a great thing, just like common sense way to say it. The mathy version is they share array. Like this is array, right? We said it stops there, it ends, or it goes on forever that way. They share that. That blue ray is the sort of the right side of this angle, and it's the left side of this angle. These don't share anything. They are next to each other, so you can't just say next to each other, but they don't share anything. Like they have their own size. So that's adjacent. True definition. But you do need to understand that. I'll say the two adjacent, like we'll be looking at an image, and I'll say the two adjacent angles, something, something, something. You don't know what adjacent means, you have no idea what I'm talking. Whoa, what's the other, do you know the other word you can use for these two? Linear pair. So linear pair is basically two of our definitions put into one type of image. They are adjacent, so that's the first thing that has to be true about a linear pair, but they also what? Add up to 180. So this is called a linear pair. Sometimes I might say a collinear pair because they're on the same line. Oh, what were you asking? Yeah, I kept thinking you were asking, wanted to answer a question, or I wouldn't have. Yeah, can you just come take it? I'm not gonna write anything on it. Sorry about that. So it is a linear pair. That's another big one I will use a lot. And it. I leave it back here. You grab it. I know, I'm just playing around like, like, hey, look, I keep rolling off those.
I was wondering where it went.
Me too, actually, I wasn't one. All right, so linear pair is a big definition you gotta know. So what does complementary mean? You said supplementary is 180, so what do you think complementary would mean? What number is?
360.
Not 360, oh, that's good, I didn't think about 360, not 360, 90. So again, 90 and 180 are the supplementary complementary. We didn't really talk, I'll talk about it in this since I'm recording this class. How are you gonna, every year, some kids get that confused and they get them reversed. How could you remember complementary is 90, supplementary is 180? Got to keep them straight. And if you come up with a little trick, remember them, it will, again, I hate tricks, but when it's a definition, there's really no other way to do it. I don't know how, that's what I'm saying. Let's come up with one so everybody can remember. I've got one that I'll give you, but it's not, I don't think it's a great one, but it works. That's why I'm curious if anybody has their own. Say it again. But how do you remember complementary? I mean, like that has to do with seeing the lines. And you got to know the word complementary because sometimes they don't give you images. I'll tell you right now. Either one, just how are you going to remember that this is 180 and that's 90 degrees? Oh, I'm sorry. Okay, gotcha. That one. You just got to remember that one. There's no other. I mean, I guess parallel is the other one you would have to keep straight from that. Nobody has one that they use? I didn't ask this last class, so maybe they didn't either. You gotta come up with, I mean, some of you just know, why just know that's 180 by now and that's 90. So here's the only one I've ever come up with. And I'll ask other classes if they come up with a good one, I'll let you know. Alphabetically, which word comes first? C comes before S, right? Numerically, meaning as you count, which number do you get first? So in alphabet, C comes first and numbers 90 comes first. It works. Doesn't really like, there's no concept that it helps you connect, total memory thing. But if you forget on a quiz and you're like, oh, I forget which one is which, that could save you. So just alphabetical and then order in numeric order is what it's called. It just means if you win in order 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So again, they do not have to be next to each other. Sometimes they will be. A lot of times they will be. What's the measure of that angle? Looks like it could be, but how do you don't know that is 90. That's actually the trick. It looks like it's got to be close, but we do not know for sure that that is 90. I just wanted to make sure you understand. You have to see one of those to know it's 90. There are questions when they will try to trick you into thinking something's 90 and it's not 90. So just be careful. If you do not see, I mean, they could tell you it's a right angle. That was your, just go back. They could tell you it's complementary. That would mean it's 90, or the two angles are 90. They could say you have a right angle, or they could put that symbol in there, but somehow they have to give you information that tells you it's 90. If you do know it's 90 and all we do is draw a line through it, that's back to little plus little is big. Those two angles would have to add up to 90 if I started with 90, which means those two angles, and again, I'll just write numbers for now. Angle 1 and angle 2 are complementary angles. They would have to add up to 90 in that. And just like supplementary, they don't have to be right next to each other. I could have angle 1 over here. I could have angle 2 over there. And if I tell you they're complementary, they still add up to 90. They do not have to be next to each other. Just any two angles that add up to 90. Just note, complementary just means they add up to 90. They don't have to be next to it. They don't have to be adjacent. So that's pretty much all three of those. You'll see a bunch of that over and over and over again. I just kind of introduced it now so that we can see it a few times before we get there. Any questions? I think it is actually in the next chapter. But... all right. Next lesson. I turn, oh, no, that is the next lesson. Speaking of next lesson. Oh, back, I gotta go backwards. It's like, where's the, okay, so turn to, did I tell you to circle the little images that say construction, like just the word?
Yeah.
Just circle that, page 63 and 64. You have one on each page. Just circle it. I'll do something with it eventually. We did that problem. If you weren't here, you may want to circle example 2. That is on your quiz Tuesday, not the exit ticket, the quiz Tuesday. So that's so on your quiz Tuesday, you have some little plus little equals big stuff for angles. You have bisector stuff. And what's the other thing we're going to get to? I don't remember. We'll get to it and then I'll tell. Oh, vertical angles. Vertical angles in linear pairs. That's all that's on your quiz. Not a lot. Probably 4 questions, if I remember correctly. So you may want to write, actually, because I'm recording, I'll write it down. So you have some little plus little equals big stuff. You have, and you have to keep straight which one to do which way. That's the hard part. Individually, when we're just on this one topic, you know how to do it. But then when you see 4 questions and each one is a different topic, you have to know which one works which way. You have bisectors, which we did both of those last class. We actually did, I think, introduce the next 2 in this class. Well, I didn't in other classes. You have linear pair stuff. What's that mean? We just say linear pair mean. Yeah, that was the bell work problem. You have a line, and all we did is create 2 angles from a line. So that means they have to add up to 180. So it's sort of supplementary, but it's more like this. That's linear pairs. They're adjacent, and they have to add up to 180 because they're on a line. And then the last thing that's on there, vertical angles, which we'll go back. I think we introduced it, but we need to go over it again. All right, so I'll let you have a second. Make sure you write that, and it is recorded. So those 4 things are pretty much your quiz Tuesday. Either 4 or 5 problems. I don't remember exactly. Little plus little equals big, bisector, linear pair, vertical angles. Oh, I already drew it out. I'm just I'm gonna redraw. Anybody writing? Eight minutes. Oh, here just why, if you're already done, I added some problems. I'll show you in a minute what I really needed. Oh, should write that up too. Actually, I don't remember the numbers. I'll write it up. So just make sure I tell you these problems. If not, you need to take a picture. This is your quiz. You know, like those 4 things. This is where you do problems. And there's some examples. Like I said, example 2. Don't forget there was a check problem at the top of 65 on bisectors that you can also do. A bunch of those problems are on bisectors. And now we're sort of on example 3, page 66. All right, so there was a topic that we barely got to, didn't even get to it in some classes, but it is one of the biggest concepts. I know I've said this a lot, but we're at the beginning of the year and we're learning a lot of things that we will see the rest of the year. So it is one of the biggest concepts for the year. If you have 2 straight lines that cross, oh, I don't like that. Make them more exaggerated. There, more like the picture. 2 lines that cross. We form angles when we have 2 lines that cross, right? That is an angle. Oh, I don't need it, but that is an angle. And then, oh, you stink. That's pretty cool. That is an angle there. And then there's an angle, another big one over there. So we form angles, but there is a very specific word slash relationship that you have to get down. You will see it the rest of the year. Even when we're doing circles at the end of the year, this will be still part of the lesson. So the opposite, oh, first of all, the measure of this angle here, how does it relate to the measure of angle, the angle like this part of the angle out there? It is the same. If you don't understand that, you just need to write it down and memorize it. An angle measure doesn't change just because I try to copy it. That's not very good. So if I had a teeny tiny angle here, and let's say I copied that angle and I made it here, but then I extended it way out. But originally I just copied this, like this here was copied and put here. Like I said, fantastic artist. But I just extended the lines. They are the same measure. It doesn't get bigger just because the lines get longer going on in a direction. My first year I taught geometry, I just assumed everybody knew that. Not everybody knew that at all. Oh yeah, yeah. If you want to grab. Nobody was waiting to that. So you have got to understand the length of the ray part basically that goes on forever has nothing to do with the measure of the angle. We measure the angle way down in here. I mean, as soon as you have two itty bitty tiny rays that start, you've already set the measure of the angle. You can continue them forever. It does not change the measure of the angle. So that every year I kind of forget. Oh man, I forget that isn't obvious to everybody, that we didn't always fully understand that when we learned about angles. So if I'm looking at that angle there, the rest of it doesn't matter. Understand that. So here's the part you need to, the concept I said that will come up for the rest of this class. This angle, so this whole, the reason I explained that, it's going to just kind of outlining the whole angle. All of that's still the angle. Goes on forever. As long as those lines go, it keeps going, but it doesn't ever change. How can I do this? I'm not going to do that. It worked last class. I don't understand why it's not. That is so weird. So there. That worked. Aha! That did not happen last week. Anyway, so that whole angle over there that I was trying to color in, that has to be the same measure as that. Opposite angles. You need to use your own words. These two angles, whatever you would call them. I call them opposite. Sometimes I'll say the angles across from each other, but use your words. Whatever you would call that angle there and that angle there, whatever you would call them. Those angles have to have the same measure. No exceptions. Same concept. These angles here are across from each other. That angle there and that angle there have to have the same measure. Big, wider have to have the same measure. No exceptions. And that will come up with any image where you see lines that cross. So kind of any image you could say where you see an X. There is an X in that image. So you have that scenario. The opposite angles would be congruent. If that's 138, that's 138 across from. Here, we got lines that cross. And this is why it comes up so much. It's because virtually in every image, every shade, you're going to have some lines that cross. Because they're going to keep bringing that back up. You don't actually have lines that cross here. Nothing goes to the other side, so that would be an exception, but it happens a lot. You've got to know immediately that angles across from each other. If they are dead straight lines and cross, they have to be dead straight lines. Those angles are congruent. So again, two lines that cross. That is true and that is true. What are those little symbols that I just drew in? What do they call them? Well, the angles are vertical angles, but what are the little symbol things I drew in? not degrees. I think that'd be a little circle. What'd you say?
So.
No, it kind of looks like, because again, if you draw a circle through every angle, they have to total 360. That?
It's a good draw game.
Well, they mean something. That's what we got to get to first, and we'll explain how you could see things.
The up symbol. Same.
That's, I believe, the correct answer. I kind of sort of heard it. So there, so these were angles. I'm going to kind of, you got to understand what these things mean. So that's why I'm taking this long, even though it's really a pretty simple complex or concept. What do those lines mean? We did it, remember? In line segments, I said if I draw a bisector, what do we say bisector means? Bisector does what? It cuts something in half, right? So we said if that is a bisector right there, that is the same length as that. What are those little? So what are these telling us over here? Because it's the same concept as that. Same. If they have the same number, again, it's not about where they are. This one's a little farther out and is bigger than that one. Doesn't matter. There's one of them in there. If there's one of them in there, that's telling us those are congruent angles. They are the same measure. These with two are telling us the two angles with two are congruent. If it's a 1 and a 2, then they are not congruent. Well, in this case, I was just going to ask, what would be true about the one with the 1 and the 2? Oh, hold on, I'm going to call on somebody for that. Janelle, I never called you. So they're not congruent. We got to do the exit ticket. These are not congruent because there's a 1 and 2, but there's something you have to know about those two. It's on the quiz. Where are they at? What's true about them? They are adjacent. What else is true? I'm going to give you a hint. Put all your stuff up. What's that mean? What did you say it? They add up to 180. So you also have a linear pair as well as vertical angles. That's why that comes up a lot. It tests you on vertical angles, linear pairs, all kinds of stuff. I'm going to do all the problems online and post it. You're going to need to watch that because we didn't really get a chance to practice them. They're not super difficult, but you need to practice them. Where are the other exit tickets? Oh, there they are. All right, so I'm going to pass them out in a weird way again, so you'll get one. Don't worry. Yeah, we do have exit tickets. As soon as you get it, get started. I know.
The 30th.
Somebody just said 30th, I believe I heard. Yeah, I mean, zero noise, zero noise. We got people taking the quiz and it can be stressful. There's some algebra on this, so the exit ticket. Ah. I'm not gonna set a timer. I'll tell you. Let's see. No, you can't give them that version. Different versions, and they have to go on specific spots. Anybody not get one? All right, so again, make sure you set it up correctly because that's already 1 point. And then try to do the algebra after that. You only have to solve for x. You don't have to plug it back in. Here's You can leave your calculators at your desk and the next class is gonna need them so they can travel. If you didn't put your whiteboard up, you don't really need to, because the next class. Maybe it's really easy. I'm gonna have it grab it just in case. I'll need to go faster. Again, please do your own work on exit tickets. Make them pretty easy, but if people are sharing, then they gotta become hard. All right, that. Yes. People are still working. Right. If you get the setup, remember you get 1 point if you can just set it up correctly. That already hit stop. Man.